Right, good afternoon. So at this point we're looking at, this morning we looked at the real number system, not so? And I asked you to draw a table, okay? You guys finish the table? No, okay, I'll give you 2 minutes to sort out the table quickly, okay? Okay, the table I asked you to draw, the one is natural, whole, integers, rational, and irrational numbers. Not so. They asked you to do the real column as well. No. Real number. No. Okay. All these numbers, if it's any of these, it is a real number. Okay. So in the table I want you to write 1/7, then -3, then the square root of 9/16 and so on. Okay. Okay, so before we go into the table, where we have to complete rational, irrational, all of those things, I'm just going to explain to you what irrational numbers are. This morning we did rational numbers, now we're going to look at irrational numbers. Okay, so before we go into that, what I want you to, let's read it first. We are told that irrational numbers, you see the Q, without the stroke on top is rational. The Q with the stroke on top is irrational. Okay. All finite, all infinite, non-recurring decimal numbers are irrational numbers. You guys understand? So he said all infinite, so the number carries on forever. Non-recurring, if it's a recurring number, what type of number is it? It's rational. We spoke about this morning. No? So if it's all infinite, non-recurring decimal numbers are irrational numbers. Square root of non-squares, positive non-square numbers. The square root of positive non-square numbers are also irrational. Like, what's the square root of 4? What's the square root of 4? We say it's 2. What's the square root of 9? 3. So what's the square root of 5? Not nothing. It can be determined. But the square root of 6, square root of 7, square root of 8. So all these numbers here are the example of positive non-squares. Can you see that, people? So if you had to put this in the calculator, I know you're not supposed to be using a calculator, but the square root of 5 on the calculator, you press SD, standard decimal. You see, that is an example of a non-terminating decimal number, or an infinite decimal. Can you see that, people? It carries on. Is this number following the comma? Is it following a pattern? No. So it's not rational. There's an example of irrational number. Square root of 6, same story. Square root of 7, same story. But different numbers, of course, no? Square root of 8, same story. Can you see that? Square root of 9, that we know is irrational. Can you see that, people? So if the square root cannot be taken, the number is not a perfect square or a perfect cube, then you get perfect cubes again. What's the cube root of 8? What's the cube root of 8? 2. What's the cube root of 27? 3. So that means to say that what's happening to the square root of 9? Sorry, the cube root of 9, the cube root of 10, the cube root of 11, and so on and so on. So these are examples of irrational numbers. Also later on, you will call these numbers surds. Okay. So these are example of irrational numbers. Okay. That's why I say the cube root of non-cubes is an example of irrational numbers. So if you're looking at Did you write now that definition down? Am I talking too much? Not yet. Okay. So example of irrational numbers, number 1. You don't have to write these examples down, it's in your booklet there. Number 1, 0,438147, and the dots at the back mean to say that the number carries on. So that's an example of an infinite decimal number. Can you see it carries on forever? Is it following a pattern? No, so it's not recurring. You guys understand? Get the picture. You see that symbol there in number 2, what is that? You don't know what that is? It's pi, yes. And where do you use pi? In a circle. When you're working out circumference of a circle and we're working out the area of a circle, then we use pi. That there is approximately 22/7. But isn't 22/7 a rational number? Yes. But you see that it's only an approximation of pi. It's not exactly pi. But pi itself, in its form, here is a calculator now. Pi, press shift, there's the pi here at the bottom, on this button here. Okay? So you press shift, pi. Why? Do you want to activate any yellow key on this calculator? You press shift. Okay? Is that number terminating? No. Is it recurring? No. So this is another example of an irrational number.
Mr. Bodin?
Yes, miss?
Sorry to interrupt. I've got a parent on the line that needs to know if grade 8s and 9s are allowed to use calculators during cycle tests.
No, miss. The grade 9s will use calculators in the term 3 and 4.
Okay. And no 8s, not?
No 8s, miss.
Thank you, sir.
Okay, ma'am. Alright. So pi, as you can see there, is an irrational number. So why did they say 22/7? 22/7 is only an approximation. It's a number close to pi. If you look at what pi is actually, 3,14159. 3,14159. 22/7. 3,1428. Can you see there on the third decimal already it's different. But this is a recurring number because this is going to go 142,857, 142,857, 142,857, and so on and so on. You don't see it here because why? The calculator only display 12 digit whatever. Does it make sense? Yes, Michael. Your hand is up. Right, you guys understand? So pi, that is irrational. 22/7 is rational. Why? Because that's a fraction. Alright. The other say pi is approximately 3,141,529. The number carries on. Root of 10, we spoke about that. The cube root of 20, we spoke about that. Okay. So let's come back to the table then. Let's see what's the next thing. Now they say note, all decimal numbers in the example above are infinite. They are non-recurring. The root of 10 is 3,14 has been rounded off. Now the square root of 10 can be written as 3,16 if I round this number off here. You guys understand? We say to 2 decimal places. But now 3,16, that number itself, is it rational or irrational? It's rational. Why? Because it's a terminating decimal number. You guys understand? But the root of 10 in that form, insert form, is an irrational number because that number will carry on forever. Okay. You round it off to 2 decimal places, therefore the root of 10 is irrational. In B, list 3, the root of 5 is irrational number, but the root of 5 squared. Why? What does square mean? The number must be multiplied by each other twice. So the square root of 5 times the square root of 5 is the square root of 25. And what's the square root of 25? 5. Okay. So the square root of 5 squared is also rational. Summary. So there we are given an example of it. Okay. So I ask you to draw the table. So let's go to the table. Right, so what I want you guys to do is to complete the table. We're going to do 3 at a time. So I will give you a chance to answer 3 and then we will carry on and so on and so on. So you got 9 over 16. Okay. So we're going to do the first 3 together. Alright. Remember, who can remind us what natural numbers are? 1, 2, 3, 4, 5, all the way to infinity. What are whole numbers? 0, 1, 2, 3, 4, 5, all the way to infinity. Integers? Negative 1, negative 2, negative 3, negative 4, negative infinity. 1, 2, 3, 4, positive infinity. Rational numbers? It's numbers that can be written as fractions. Recurring decimals and terminating decimal numbers. Irrational numbers? Non-recurring, non-fractions, and infinite decimal numbers. Not so? Right. So 1 over 7, is that natural? Does that belong to that set? No. Does it belong to the natural set? No. Does it belong to integers? Integers? No. Rational? Yes. Irrational? These two. The number can't be rational and irrational at the same time. It must be one of the two or none of the two. Okay? Either or. Okay. Questions? Do you have a question? Right. Negative 3. Is negative 3 a natural number? No. Is it a whole number? No. Is it an integer? Yes. Is it a rational number?
No.
Okay. If you're looking at negative 3, can it be written as a fraction? Yes. Negative 3 over 1. So is it a rational number?
Yes.
Is it irrational?
No.
Square root of 9 over 16. What is the square root of 9 over 16? 3 over 4. Can you see that? So, is 3 over 4 natural? No. Is it a whole number?
No.
Is it an integer?
Yes.
Remember, what are integers? 0, 1, 2, 3, 4, and so on. Minus 1, minus 2, minus 3. So is 3 over 4 any of these numbers here? No. So why are you shouting out every time yes? So it's no. Is it rational? Is it an integer? Irrational number? So you guys understand what I did there? So now you do it for the next 3 for me quickly. Okay? Then I will do it on the board again. Okay? Alright, you guys finish? Sorry? Yes? Okay. Okay, I'm just keeping the questions in focus. Otherwise, I must go up and down, okay? But you don't have to delete your answers. So you got negative the cube root of 8, 0,35, the 3 is recurring and the 5 is recurring. We got 2 pi, and we got the root of negative 3. Okay, I just also say 3 at a time, no? So what is the negative cube root of 8 going to be? Negative 2. So when I complete the table, when I tick and cross, I tick and cross on negative 2. You understand? So is negative 2 a natural number? No. Is it a whole number? No. Is it an integer? Yes. Is it rational? Yes. Is it irrational?
No.
What type of number is this? It's a recurring decimal number. Okay? Yes, Michael? Why's your hand up? You wanted to say it's a recurring decimal number. Okay? So recurring decimal, is that a natural number? No. Is it a whole number? Is it an integer? Is it a irrational number? Yes. Is it an irrational number? Okay. Now pi is the number we spoke about earlier. Now 2 times pi would that be rational? No. Will it be natural? Oh, sorry. Natural? No. Whole? No. Integer? No. Rational? No. Irrational? You guys get the picture?
Yes.
Right. Sorry? When will it be irrational? Just make a note there. Irrational numbers will occur. I gave you the note earlier on. You're probably sitting in the sun at that time. I see you sitting in the shade now. Irrational numbers, or infinite, non-recurring decimal numbers, are irrational numbers. Infinite means to say it carries on forever. Like this, it carries on forever. That way, it carries on forever. Okay? Not following a pattern. It's not following a pattern. Does that make sense? Okay. Right. So what I'm going to do is, I'm going to give you a couple of minutes to sort out the next 4. So now you're going to do 4 for me. Okay. I'll pause again. Sorry? Oh, I didn't do that one. Negative root 3. Let's do that one. Negative root 3. Root negative 3. Now coming back, negative root 3. Okay? What is the answer to negative root 4? 2. What's the square root of 4? That is 2. Negative. People, what if I take that, okay, and I say 2 squared, what is 2 squared? 2 times 2, which is 4. So the square root of 4 is 2. So if you're saying that is negative 2, which is incorrect, okay? Then that means you say that negative 2 squared. What is negative 2 times negative 2? Positive 4. So could that be correct? No. So there's actually no solution on that. So if you take, let's put it in a calculator and see. Square root of negative 4. Math error, which means to say it doesn't exist. So you can't take a square root, or any even root for that matter, of a negative number. Does it make sense? You can't take a square root of a negative number. So if you're looking at negative, the root of negative 3. So what would that be? Is it natural? Is it a whole number? Is it an integer? Is it rational? Is it irrational? No. It's nothing. Else. It doesn't fit in any of these categories. Do you understand? Right. Do the next one. Alright. Let's look at the next form. The same. I will see, don't worry. You don't have to tell me every time. Okay. So the next one is the cube root of 8. 1 and 1 over 6, 4. And the square root of 3 squared. Okay. What's the cube root of 8? 2. So I'm judging on 2 now. I'm thinking on 2. That's all. So is 2 natural?
Yes.
Is it whole? Yes. Is it integer? Is it irrational? Yes. Is it irrational? The next one. 1 and 1 over 6. Is that natural? No. Is it whole? Is it integer? Is it rational? Yes. Is it irrational? 4. Is that natural? Is it whole? Is it integer? Irrational? Irrational?
No.
Now, the square root of 3 squared. What's the square root of 3 squared? Just told you earlier on. 3. So we judge you on 3 now. Is 3 natural?
Yes.
Whole?
Yes.
Integer?
Yes.
Rational?
Yes.
Irrational?
No.
You guys get the idea? Yes. Do the next one. Okay, you guys finished? Not yet? Okay, can I start answering? Yes. The cube root of 9, is that the perfect cube? No. So is it natural?
No.
Is it a whole number?
No.
Is it integers?
No.
Rational?
No.
Irrational?
Yes.
4,5, what type of number is that? Terminating decimal. Or finite decimal. Not so. The number stops. So is that natural? No. Is it whole?
No.
Is it integer? How do you get yes? What are integers? Integers are positive and negative whole numbers only. Not so. So it's no. These are integers here. And of course to infinity and negative infinity. Is it
Yes.
yes. Is it irrational? How can it be irrational and rational at the same time? I told you, you can't be both at the same time. 0, 1, 2, 3 recurring. Is it natural? Is it whole? Is it integers? No. Is it rational? Yes. Recurring numbers are rational numbers. Is it irrational?
No.
Square root of 10. Is that the perfect square?
No.
No. Is it natural?
No.
Is it whole?
No.
Is it rational?
No.
Is it is it integers? No. Is it rational? No. Is it irrational? Okay. I'll give you a couple of minutes to do the last one. The last 3, sorry. That's how we give it to you in the exam as well. We give it to you in a table format like that, and that's how you do it. Normally it counts like 3, 4, 5 marks. Yes? You can just tick the ones that are if you don't want to cross out the ones that's not. Okay. So 2 root 8. Is that is a square root of 8 a perfect square? No. So is that natural? No. Is it whole? No. Is it integers? No. Is it rational? No. Is it irrational? Yes. The square root of 2. What's the square root of 2? It's an error, not so? So is that natural? Is it natural? No. Integer? No. Whole number? No. Rational? No. Irrational? No. This number doesn't exist to us at this point. Yes, Michael?
So for 2, the first and second one is supposed to be 8.
How do you mean 8?
Because of the square is
What is the square root of 8? Can't. So that's a third. It's irrational. So this is a infinite decimal. So is it natural? No. Is it whole?
No.
No. Is it integer? No. Is it rational? No. Is it irrational? Yes. Okay. Any confusion here? Right. So what I'm going to do is I'm going to give you a couple of numbers here. I want you guys to complete this for homework, okay? Okay, it's going to be 0,8 recurring. Write this down, please. 2 and 1 over 16. Pi, negative square root of 3. Yes?
What is the third number?
5.
Oh.
Then we got 2. The square root of 16 over 25. 1, comma 3, 5, 3 is recurring and the 5 is recurring. 0,75. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers that I want you to classify as we did before. Okay? For homework, yeah. Well, you can do it now. Let's do it now. You have no homework to do. So let's do this now. Yes? Just put it on the table. Thank you. Yes? Yeah? Thank you. Okay, I'm going to answer those questions now. Okay. You guys finish? Oh, the bell's gonna ring now. Okay, let's do it. Okay. What I do suggest is you rewatch these 2 lessons this morning's lesson and today's lesson as your homework. Okay. Say, I know the learners always have problems with these questions. So here's an opportunity to rewatch it. Make notes for yourselves and let me know which aspect of today's lessons you didn't understand. Okay?